Oh, today we got in the mail the new grid tie inverter. Wow. This is the 400 watt second generation 2 grid tie inverter from Greenergy Star. First of all, I found it was nicely packaged, double boxed, and the cable here seems to be fairly good. It's probably to North American standards for whatever the power output really is. I'm trying to see if it says on there anywhere what gauge it is. It has a bunch of stuff, but just doesn't want to tell you the gauge. So they are very good at making the outer shield look like it's compliant, but the inside wire is minimized to get by as cheap as possible. So we'll see. It doesn't seem to really have much of any rating at all on it. It's got a bunch of S's and pluses and, you know, maybe a few BS's. We'll get her out there and take a look. It's a nice small little guy. It does have a little bit of weight to it, so the heat sink is fairly good. I thought it was going to be cheaper aluminum than what it actually was. Plus it has information on the back. I haven't had a chance to read it all. Warnings and explanations of the lights, so it seems to be fairly good compared to the other ones that I've seen that don't really tell you much of anything. No doubt that this is exactly what's on their website, because that's what the wind turbine was, exactly what was on their website. Features, you know, bullshit about your meter turning backwards. I don't actually expect a meter to turn backwards with this. It's supposed to be 400 watts. Input, solar and wind, 10.8 volts to 28 volts. DC. Shutdown voltage is below 6.5. So that's quite a bit low as far as I'm concerned. But maybe not. That might still be okay for a battery. I usually have mine shut off at around 9. Peak inverter efficiency 92%, but it doesn't say what average inverter efficiency is. Maximum input current 15 amps. Overcurrent protection 30 amps. Now this 15 amps, they didn't tell you that on the website. They deliberately held that back, so I'll have to do the math and see. At least I didn't see it there on the website. Output, it's saying 400 watts, right? Now what it's saying here, rated at 27 volts input. So again, they bullshit you to try to get the wattage up. But 400 watts output power at 27 volts seems to me like a bunch of BS. Power factor rated at 15 amps and 18 volts input. Well, they just seem to keep changing the voltage to get the specs that they want to achieve. I don't really expect it to do a heck of a lot, but we're going to see. By the heat sink and the design, it looks like it's a KD model. I'll open it up later and take a look. But that's like Kevy's 1000 watt grid tie. The same type of heat sink and the same fuse covers. They got a 30 amp fuse and its maximum load or draw is 15 amps. So they're allowing themselves a lot of excess. We're going to see what happens with it, and like I say, it's a small little guy. We'll see how it works out. It was cheap. I figure I'm hooking it up to 2 panels, so it should be fine with 2 100 watt panels. So we're looking at about 6 inches to the outside of the brackets by about 7 inches. So 6 inches by 7 inches. So it's a nice little small one. And we're going to see how she works out hooked up to batteries and see what the truth of the matter is. It's going. The little red fault light comes on for a minute. Well, not exactly a minute, probably for about 10 to 15 seconds, and then it starts doing its little rotation thing. Right now we're on 12 volts, so we're probably right near minimum. So we're at 12.75, and at 12.75 volts we're producing 10 watts. Wow, 10.4 watts. $123.5 volts, 60 hertz. 0.2 of an amp. Now, ain't that a lot of bullshit? Ha 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 ha. Now, that's your high. Okay, so right now we're producing 10 watts. I'm producing 8.7 watts. She ain't doing too much, and that's at 12 volts. Okay, what we're going to do now is we're going to bump it up to 26 volts. Wow. 55, 48, about 50 watts. A whole 50 watts. So anyways, we're getting right now, we're getting about 50 watts. Now, this wire isn't very heavy. It is starting to get a little bit warm, but not heavily. But the point is, coming from a battery like this, there should be no problem getting 15 amps out of it. We're going to see what happens when we take it outside and hook it up out there. Before I take it outside, I wanted to just take a quick look and see what I could see inside, and this is it. And from what I see in here, it's very similar to the KD, like I figured. I don't see actual KD name on there, but they got a piece of tape or something there, probably blocking the name. But it's definitely down in that corner. You can see down there. Probably won't focus. That red wire's in the way. It's listed as a 300 watt inverter. So what they've done is they've listed it as a selling it as a 400 watt, and they're actually using a 300 watt, so they're lying going out the gate. So right there is more bullshit. And this, I'm sure, is one of those generic ones, probably made by KD. I see them, they sell them on eBay. The company will advertise that you buy them and put your sticker on them. Right? So you can put your sticker on the units and sell them under your name. I've seen them under the name of High 10 and a few other names. We'll see what it does when we hook it up to the solar panels outside. Alright, we're outside now. And woo, that thing's whipping around there. We'll see what we're getting here. 124 watts. So I think that's about as much as it's going to produce. 125 watts. And that's under full sunlight. And that's with 2 panels hooked parallel. So I'm at 12 volts, but 12 volts no load is 20 volts with these. So you don't want to go in series because you'll go up to 40 volts. So what I'm going to do now is I'm going to disconnect one panel and see how we do. We're at 66.4 watts with one panel, and as you can see, the current has slowed down on the little spin thing there. What I'm going to do is check the other panel to see how the panels are, because this is the first time I've actually seen what their output is. So function is 0.6 amps. So here we are at 66.7 watts under full sunlight. Okay, 66.5, 66.7, so we're doing good. And what I've done here with this cord is I've made the backwards attachment. This one I did find out does go in the opposite direction, but I get a different reading. So this is the proper way to do it, where you're actually pulling out of the meter. So now what I'm going to do is just shut it off by unhooking the AC here. Then it goes to fault. And I'll go over to the solar panel at the back and connect up my other panel. Now this is a good way to check to see if both of your panels are outputting equally, because I had the connection here. So I just disconnected one, and then I connected it back up and disconnected the other. So you only need to disconnect one lead. Okay, so we're back together. And we should have about 120 watts going through there. Okay. $86, $93, $120, $125, so we're at about 125, 126 watts with both panels. And see, she's just racing there like that. Now, 125 is nowhere near 400. Yeah, but I got to do the math and see. Next thing I got to do right now is pull out a meter and see what my voltage is. Okay, so we're getting 125 watts, and our voltage under load is 14.2 27.29. So basically 14.5 to 15 volts under full sunlight. So that is a little low for getting the maximum out of it. So that's the most I'm going to get here, because they rated it at 400 watts at, I think it was, what, 29 volts or something like that, or 27 volts. I'm not sure what they said in the manual, but it was nowhere low as 15 volts. But that's as good as you're going to get out of these things if you're using 12 volt panels. Now I could hook them up in series, but I hook them up in series, I'm probably going to be over, because I'll be at 30 volts and the no load voltage will be at 40, so I'll blow the thing. So that's the best you're going to get with one of these. So although they rate them at 400 watts, the actual board says it's a 300 watt, 125 watts. I'm going to go in because I'm getting hot. But that's it, 127.5. So that's peak that I'm going to get out of this thing. I may get more if I add more solar panels on. But then if you do that and the thing starts heating up too hot to the point where it's going to kick on the fan, you're going to start eating up your profit, and it's going to start slowing down the inverter to cool itself. So oh, the fan's coming on already. So that's bullshit, man. Okay, so I took the meter off it, and she's starting to build back up again. And I did hear when I plugged it in, the fan came on to cool it for a few seconds at full. So I guess the fan goes at different levels depending on how hot it gets. But I can definitely hear it buzzing. I can hear the inverter. And that's for now. Here I am, checking it out again. I installed the grid tie inverter on the back here because I really got no place to put it in the house. And I need it to be semi-portable, so I lose a bit of power going into the extension cord and then into the house there by the run, but I lose less than if I was running DC. So what I've done here is I've done my second last adjustment here. I just laid it back for May. It's supposed to be for this area 62 degrees for this year. And I just adjust that bolt at the back, and then I adjust the adjustment. Now the beginning of next month, which will be June, it'll go to 70 degrees, and then it'll start going back down as we get towards winter, and then park in December at 22 degrees. Now, as you can see, there's no sun right now, but there's where the grid tie inverter is. What I'm going to do is I'm going to tape a piece of plastic along here just to keep any rainwater from getting down in that crack there, and following that down along the edge, and I'll just have it come down and hang, you know, just to keep any driving rain out. It's not going to get up in there, you know, just the way it is. I got to get the hose out and get the poop off there too. I see my board has started to warp. I knew that was going to happen because the board was actually a little too thin. It's just what I happened to have at the time when I was throwing it all together. But you know, I'll look at redoing it for next year. I still want to put something on here. I was going to put some sealer on it that I had last year that I had used, and it's all turned to gel, leaving it out in the shed. Now, it stayed in the shed for like 10 years, no problems. Last winter it turns to gel. So anyways, I drilled a little hole there just the other day. That's because the rainwater tends to pool around that area, so what I can do is it just goes down the hole there now, most of it anyways. And what I do want to do is get some exterior paint, give it a couple coats of exterior paint. I still got the battery set up there, but right now I'm going to be trying it with the grid tie. See, because with the battery I get about 3 days of all my outdoor lights, so I should say 3 nights with all my outdoor lights. And with the grid tie inverter, I'll probably be more beneficial using that to help offset my air conditioning costs and other hydro costs during the summertime. I can just hook those lights back up to the power supply. I got to redo them anyways. I got to get some of the 12 volt landscaping lighting wire and get rid of this mess here. That thing up on the top is my light sensor that I built. I bought a little light sensor that works off of IR, and I wired it up with a 12 volt automotive relay so that I could draw more current off of it, so I can draw up to 20 amps at 12 volts with no problems off of that line. And I stuck it in a pill bottle and aim it at the sky, and it works perfectly for dusk to dawn applications. It works a lot better than the photocells that they put in these stupid lights that you buy. And that controls all those there. Ooh, what's happening, man? Oh, it must be a bug. Oh, it was a bug. I seen this black mark. Yeah, so anyways, it runs all these lights, and these lights have been converted over to LED modules. So I did those a few years ago, and they're still working good. And this guy here is a 10 watt 12 volt floodlight. So it's a 10 watt LED. That's your best deal for the money. I think that they would cost me, those ones, $13 with shipping from China. So for the money and the amount of light they shed, they're the best deal. I bought these ones over here. I don't like these as much. These are spotlights, so they're more directional. And these ones here, I have them disconnected in the winter time because it's just too much load on the battery in the wintertime. I don't get a full night out of them. As it is in the wintertime with the solar panel charging the batteries, I get about 4 to 6 hours. So again, I'm running all these. I'm running a couple more there, running more of them along there, and then 2 more on the side of the barbecue. This here just runs off of the AC, and this is a rewired corn light that I did. They had the wrong ballast in it, so I got to keep it. I took the ballast out and I added up the LEDs and hooked her up in series, put a bridge rectifier and a cap in there, and run it like the old Christmas bulbs. Works good. It's actually underpowered, so it should last a lot longer. Gives lots of light for at night. It draws about 8 watts. I think I tested it at. So it was originally, I think, 14 or 15 watt. And I'm getting about 2/3 the light out of it. And at about 8 watts, I think it is. So in conclusion, the Greenergy Star scam. Any of their products that I've had have always been heavily falsified on the specifications. This little guy here, it's okay. I would recommend putting 1 per solar panel. Like I say, from the tests that I've done, I think that their best spot would be at about a 150 watt panel. 200 watts going in is causing the fan to turn on, so you're oversaturating it at that point. The fan doesn't come on heavily, but it does come on slowly, so you're already eating up some of your generated power, as well as the fact that the evidence is there. You can plug in 1 panel and you're getting 66 watts. You plug in 2 panels, you end up getting 125 watts. It doesn't add up. And the reason it doesn't add up is because the efficiency of the inverter. The higher you push it, the less efficient it gets. So you have to reach that efficiency spot where you're going to have good, efficient conversion of power. And these units, first of all, they're falsified. They're claiming it's a 400 watt. The board doesn't lie, it's a 300 watt, and when they say 300 watts, you can really expect to get half of that without oversaturating the inverter. So you're looking at a 150 watt maximum. Ideally, you're probably going to get 130 watts out of it. If you were to hook it up to 150 watts, it would probably run at better efficiency. So ideally, this little guy is probably suited for 2 75 watt panels, maybe 80 watt panel on its own, or up to 150 watt panel. They recommend in here minimum 80 watts. So you need a minimum of 80 watts, but you probably would do good with 2 75 watt panels hooked in parallel. Again, they hold back critical information, which is how they're deriving their specs. 400 watts. On their website, they don't include the rated at 27 volts input. They got your power factor, whatever that is, at 0.99. Rated at 15 amps at 18 volts. So what they're doing is they're changing the voltage at which they do these measurements to get the desired ratio to make you want to buy the item. So not very efficient. As far as I'm concerned, at $130 to $150 for the unit with tax and shipping, slightly overpriced. At the price I paid for it is slightly overpriced, and that was the sale price. I think they were trying to sell these things for 170 bucks, these racketeers, and I mean, that's just crap. So anyhow, my conclusion is that these are nicely suited, 1 per panel, you know. So I haven't checked out any other brands, being able to compare the in-out specs on them. with what they actually produce. That's probably your best way to do it, is try to find the cheapest inverter, the small ones, because I think in the long run they're going bigger, trying to get bigger money out of it, but they're not increasing the efficiency, and they're not increasing or doubling your power. You're losing power. Like when I hook up 2 solar panels to this, what happens is I lose 5 watts over running, if I was to run 2 of them separate. So I'm losing 5 watts of power. Now that's not a whole lot, but every little bit counts with what you can extract from these things. So when you already have an inefficiency, adding another 5 watt loss, like realistically I should be able to get 130 watts out of this, I figure. So I think what I'm going to try next, if I go with any more of these, is I'm going to just look for the 250 to 300 watt ones that I see selling for like $50 to $75, and try one of those. I mean, it's probably going to be more cost effective